Hello everyone, Miss Travel here, going over 11.7, the quotient rule, our third of 4 rules here. So if you notice the quotient rule here, there's a nice little way to remember it. It says low d high minus high d low over low low, okay? And so what that means is this is the derivative of the top one and the derivative of the low one, okay? So you take pretty much the bottom derivative at the top minus the top derivative of the bottom, okay, over the bottom squared. So that's kind of our equation here. So high d low, or sorry, low d high minus high d low over low low. Okay, so that's going to be for quotient. Still, if possible, see if you can reduce, if you can simplify something into just a polynomial or something like that versus a rational function, do it, okay? So here it says find the derivative of each expression. We can keep the denominator in factored form. We don't have to FOIL it out, which is nice, okay? So what we're going to do is, if we remember low d high, so the bottom times the derivative of the top, so this would just be 4x minus its high d low, right, so the top one, times the derivative of the bottom one, all over the bottom squared. And if it's not too crazy, we're going to definitely clean up the numerator. Again, we can leave the denominator as is. Okay, and so in the numerator, we end up with 4x squared plus 20x minus 2x squared. Ooh, that 20 looks bad. Minus 1. Okay, sorry, this one looks... Oh, come on, eraser. Uh-oh, eraser's not working. There we go. Try to make that look a little bit. Wow, that didn't work either. Okay, and so combine whatever like terms we have. So we have a 4x squared and 2x squared, so 2x squared. And then we had that 20x by itself, so plus 20x. And then the 1, so minus 1, all over x plus 5 squared. Cool. And so that would be the derivative of y. Or y. Okay. Not necessarily super pretty of an answer, but it works. Okay. All right, this next one, again, low d high, so the derivative of the bottom, so that's 3x squared times the top minus the derivative of, or high, I guess, the top one. Sorry, I messed up on this one already. I usually do, I'm trying the low d high and high d low. I always have a hard time remembering that, but I was trying it on this video. But what I always do is I'll do the derivative of the top, so in this case 0 times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. Cool. And so the nice part is that first part goes away thanks to the 0. Our second one we simplify out, and that would be negative 18x squared over x cubed plus 2x squared. Nice. Okay. Number 3 here. Okay. And so number 3, we're going to go through almost can reduce, but unfortunately it's not a perfect square or anything like that. So when I solve it out, we would do derivative of the top. So that would be 2x times the bottom minus derivative of the bottom, which in this case would just be 1 times the top, all over the bottom squared. All right, expand it out in the top there. So we have 2x squared minus 6x. And then into here, since it's a 1, we've got negative x squared. What's that, plus 3? And so if I simplify that, that's x squared minus 6x plus 3, all over x minus 3 squared. Nice. Okay. And the next one, this one definitely is quite the derivative because we have a lot of terms here, right? So we could potentially take out an x, but unfortunately this 1 doesn't have an x, so I can't take out that GCF of an x and simplify it a little bit. So I just have to go for the whole kit and caboodle, right? So derivative of the top plus 12x cubed, that 1 goes away, times the bottom, minus the derivative of the bottom times the top. All over the denominator squared. Cool. And now distribute in, so we would end up with, what would that, 5x to the 6th plus 35x to the 5th. Distribute this guy in, so we get plus 12x to the 5th. Let's make sure I can actually read that. Plus, what would that be, 94 x to the 4th. Did I do that right? Nope, 84. And then you could do either way. We'll do minus this whole thing. So that would be 2x to the 6th plus 6x to the 5th plus 2x. And then distribute in that 7. So plus 7x to the 5th plus 21x to the 4th plus 7. And then go through and change all the signs thanks to this negative. So negative, 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 negative. Holy smokes. Okay, and so let's be careful when we're going through. Always look for the biggest exponent. So it looks like the 6th here. So I've got 5 minus 2. So we should have 3. Oh, I forgot all of this. If you notice, I kind of do a shortcut, do that squared, just so I don't forget about it though. Okay, so this should be 3x to the 6th. So x to the 5th, x to the 5th, x to the 5th, x to the 5th. And that's it. So 35 plus 12 would be 47 minus 6, so 41 minus 7 would be 34. Okay, so plus 34x to the 5th. Now looking for the fourths. We got a 4th here and a 4th here. Don't forget about that negative up there. So 84 minus 21 should be 63. Okay, we got that, so x to the 3rd, I don't see 3rd, I don't see 2nd. So the only two things I have left is this one, so minus 2x, and then the 7 at the very end there, minus 7, over x squared plus 7x squared. And that is your derivative. Cool? Okay, so quotient definitely it's a lot beefier than the other rules. It's got a lot more going on. Okay, so this one we're gonna set it up first before we find all the values. Okay, but it is super nice. So h prime is we're gonna do f of x divided by g of x. So derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. So g of x squared. G of x squared. Okay, and so now we're going to have to go through and find individual ones here for this one. Okay, so for the first one, we've got f prime. I'll write it all out on this one for you. So f prime of -1 times g of -1 minus g prime of -1 f of -1 all over g of -1 squared. Okay, and so as we go through this, we're all in this row right there. So f prime is going to be 1/3 times g, so that's negative 12, minus g prime, which is 6, times f, which is 9, all over g squared. Whew, getting tight there. Okay, so that would be what, negative 4 minus 54 over 36. Okay, and so, sorry to pause there for a second. I was looking, it looked weird. So thankfully I caught it now, but that g of negative 1, I was looking at g prime. I should have looked at g, which is negative, sorry, it's so squished down here, negative 12, which is 144. So this would be negative 58 over 144, which we can reduce it down to negative 29. So divide by 2 over 72. Okay. Nice. So the next two, I'll try to be a little more careful with plugging it in, but I'm just going to go through here. Okay. So the first one that I'm looking for is f prime of 3. So now we're in this new row. So f prime of 3 should be 8 times g of 3, which should be 1/2, minus g prime of 3 should be 10, and then f of 3 should be negative 3. Okay, and then the denominator is g squared, right? So it's 1/2 squared. So in the numerator, we have 4 plus 30 over 1/4, which is 34 over 1/4. And then if we skip, flip, and multiply, we'd end up getting 34 times 4, which is 136. Ta-da! All right, our last one, see if I can scoot it down just a little bit, is going to be with an x value of 2. So that top column, my eraser doesn't want to work again. Nope. There we go. Okay, so we're in this top column again. So everything's going to be with an x of 2, right? And so to start out, we've got, I'm just going to clear it so that I've got plenty of room. So we're going to do everything with an x of 2. So we've got, oops, I didn't mean to do this one, f prime of x, g of x, minus g prime of x, f of x, all over gx squared. Cool. So f prime of 2 is going to give me negative 4 times g of negative 2, negative 1, or of 2, sorry, minus g prime, so 5, times f, which is 7, over g squared. So that's going to be what, 4 minus 35 over 1, which should equal negative 31. Nice. So number 8 here, it says write the equation of tangent line in h of x in the form when at this point right here, 2, negative 7. So if you look, 2, negative 7, this was our slope right there. So we have everything we need. And so the equation of the tangent line is going to be negative 31, and then x minus 2 minus 7. All right. Number 9, we have the h of 1, but I erased it. But you guys have it. Look at, what number was that? Number 5. So the slope on number 5, which came out to be negative 29 over 72, x plus 1, because we want that opposite, minus 108. Cool. Nice. Nice. Okay. So here it says for 10 through 12, we're going to use the same equation. Okay. So it says find h prime, so find the derivative by first dividing the expression and using the product rule. Okay, so if we do that, we divide each individual, we're going to end up with 1/4 x plus 2 minus 3 over x. Nice. And so we rewrite it so they're all with no denominators. So I'll do 1/4 x plus 2 minus 3x to the negative 1. So now the derivative, h prime of x, would equal, bring that 1 down, so it'd still be 1/4 x to the 0, which goes away. That constant goes away, and then bring this one down. This would be plus 3x to the negative 2. Nice. Now for the quotient rule, we're going to take the derivative of the top. So that's going to be what? 2x plus 8 times the bottom minus the derivative of the bottom times the top, all over the bottom squared. Okay. So this one's a little bit easier to solve out that denominator, so we can say 16x squared. Now the numerator, we've got 8x squared plus 32x minus 4x squared plus 8x, oops, going too fast, plus, not plus, because we're distributing a negative 4. Ooh, a lot of mistakes on that one. So minus 32x plus 48. Nice. Now we combine, oh yeah, those guys go away. We can combine our squared, so we get 4x squared plus 48 is equal to 16x squared. And so that would be, even though it looks a little bit different, that would be good enough for the quotient rule there. Now number 12 says, okay, let's combine the two to see if we actually get the same values, which we should, right? So if I take this guy and simplify it, I have 4x squared over 16x squared plus 48 over 16x squared, which would be equivalent to 1/4, right? Plus this right here would be 3 over x squared, or 1/4 plus 3x to the negative 2, which, holy smokes, would match. Cool, and show that they're equivalent. Nice. All right, so we're going to kind of do the same idea here with g of x, right? So we have the square root of x plus 1 over 3x cubed. So first we're going to do it by doing the power rule. So with the power rule, we put it individually, right? And so what I would do is we're going to go x to the 1/2 over 3x cubed plus 1 over 3x cubed, right? And so now we want to bring it those x's out of the denominator. So we're going to have, excuse me, 1/3 x. Now I'm going to subtract the 3 up here. So 1/2 minus 3, right, would be 2/2, but I don't really want 2.5. So I'm going to put it as negative 5/2. And then this one is plus 1/3 x to the negative 3. Solve it out for the derivative now, thanks to the power rule. Bring that down, so that's going to be what, negative 5/6 x. Now subtract 1, so negative 7/2. And then this one is going to be, bring the 3 down, so those will cancel, so negative 1 x to the negative 4. Okay. Now that's good for now. We may have to change it just so we can compare and contrast for number 15 down here. Okay, so now it says use the quotient rule. I'm going to do x to the 1/2 plus 1 over 3x cubed. Okay, so derivative of the top. So that would just be, sorry, it looks weird with the parentheses. So that would be 1/2 x to the negative 1/2 times 3x cubed minus derivative of the bottom, so 9x squared times the top, all over the bottom squared. Nice. And so for the numerator, we have what? 3/2 x. Now we combine those, so that would be what? 6 minus 1, so 5/2. Minus 9x, combine those, so that would be 5/2. And then minus 9x squared all over 9x to the 6th. Whew. Okay. I can combine the first two, and so 3/2 plus 9, that would be what, 18. So that would be 18/2, so minus that, so negative 15 over 2x to the 5/2 minus 9x squared over 9x to the 6th. Cool. And so for number 15, there's a few ways to go about it to make them look similar. Again, this definitely is not the prettiest answer you've ever seen, but yeah, you can bring that 2 down into the denominator, but if you do that, then you've got to double that guy as well. Okay, so just be careful with that. You can take out a GCF with both of them. But now what I'm going to do is I'm going to split them up just like we did, 15, for the last set of problems. So x to the 5/2 over 9x to the 6th minus 9x squared over 9x to the 6th. This one's easy. The second one's easy peasy for sure, because they just cancel and leave you with 1 over x to the 4th. Right, and so here, dealing with this fraction, if I skip, flip, and multiply, I'll bring it over here, negative 15 over 2 times 1/9. So you can reduce a little bit, call that a 3, call that a 5. So I end up with negative 5/6. Okay, that's looking good. And then again, end up subtracting them, so x to the 5/2 minus 6. So that's going to be, if I cross that out and do 12 over 2, that would give me negative 7/2. All right, x to the negative 7/2. And then again, we can change this so that they match exactly, but just bring that x out of the denominator. And if you notice, that one should match that one exactly. Cool? Cool. Crazy process there, but shows that both process, both the power, simplifying with the power rule, and then just straight up doing the quotient rule. Even though they look different, they should give you the same answer. Okay. So here, 16 through 17, find the derivative for each expression. You can rewrite each expression in equivalent form. Okay. So what that tells me for number 16 is I definitely want to break it apart. I like using the power rule as much as I can. Makes, in my opinion, makes my life a lot easier. All right, so this then becomes 1/3 x squared minus 1/3. If I subtract those, this would be x to the negative 1/2. Once I've done that, I bring it down. That would be 2/3 x plus 1/6 x to the negative 3/2. You're more than welcome to try it through the quotient rule as well. And if you want to see it written down, it's in the notes on the DRHS math website. Cool. All right. So this one, big old hint here, says you should rewrite it first. Okay. So see if we can factor this numerator, which we can. Gives me x plus 2 over x plus 2. And holy smokes, those go away. And believe it or not, that makes that problem super easy. So that derivative of x is just 1. Nice. All right. I hope you enjoyed 11.7. Tell a friend.